Okay, so what we're looking at is problem 170 out of the book. And the nice thing about these to start off with, they give you the equation and its balance. You don't have to mess with that. All you have to do is worry about the problem at hand, what you're doing. And so I like to use this as a map. Okay, this is my map, where I'm starting, where I need to get. Okay, so it says, what's the mass of oxygen produced? So here's O2. What's the mass of oxygen? I got to get there. I got to find that answer. Okay? Then, when 1.840 moles of H2O2 decomposes. So this is H2O2. Right? And then, so this is 1.840. So my map will show that I need to come here. Before I can get any grams, I've got to transition that to moles of O2. I've got to go, every time you want to find grams of something else, you got to go through moles to get there. Okay, Dalton, why don't you open up page 890 in your book? Thanks. So then, the 1.840 is what we start with. And to do a mole ratio is just like what we set and did for Thursday problems. So down here, I'm going to write exactly what I have, moles of H2O2. And then up here, I'm going to go moles of O2. And then what goes in that slot would be our mole ratio. So it's 2 to 1. Any questions? Now, if we did our calculation, we'd have that answer right there. We'd have that answer, and with that answer, we can transition to grams from that. So if we know moles of O2, we can go to grams of O2. So in our next setup, okay, we'll continue the process. Our moles of O2 would go down here, and then our grams of O2 would be above. So we can make that relationship. We'll always want to do, when we go grams and moles within a conversion, moles will always be 1, and then we calculate the weight of our substance, so we can get how many grams are in a mole. So O2, there's 2 oxygens, with each one 16, total of 32 grams for 1 mole. My moles cancel out. So the units always have to cancel out. I had one student last period. She put the grams down here, and then realized, wait a second, that doesn't work out. They won't cancel. That's a good way to double check. So some students want to be lazy. I know it's laziness because they just don't want to put any units in, and then that becomes an issue. Real big issue on these multiple step problems. So, well, I'm going to give the answer for 169A for those who did the assignment. The problem before this was the same type of setup. It's a 403 grams for phosphorus. Any questions on that one? And if you would finish this setup and get the answer, it's 29.44 grams. 29.44 grams. Any questions? So those...
How do you know it's 2 moles of H2O2 to 1 mole of O2?
Right here. It's 2 to 1 ratio.
Oh.
2 to 1. So it's a mole-to-mole problem, just like what we did from Thursday to Thursday. Yep. Moles tell you what the ratio is so that you can get the right number of moles. Questions, comments? Okay. We're going to move on. This is the setup for 172. This is the formula for 172. Or the equation. So, again, I just like to write down where I'm at, where I need to go. So it says if you have 62.5 grams of Fe3O4. So that would be 625 grams of this. That's what I'm starting with. It wants to know how many moles of hydrogen gas are also produced. So I want to get down to here. Okay. So anytime we're doing any problem, we got to have everything in moles if we're given grams. So the 625 grams will start our starting point. So then down below has to be the same unit and same formula. So it would be grams of Fe3O4. So they'll cancel out. And so what I need to do is I've got to get the moles of Fe3O4 before I can transition to get moles of H2. I can't go in one step. Some students like to go one step. They'll put grams of Fe3O4 down here and they'll put 4 moles of H2 up there. Well, they're not the same thing. You can't go grams of one substance and figure out moles of another substance in one step. So you got to go to moles of Fe3O4. And so you do that by figuring out the weight. So you take the free ions, you take the 4 oxygens, you add them all up, and then that's what you're going to get your molar mass of what 1 mole is going to be, just like we always do. It's 231.54. Should be 231.54 to 1. So now I'm here. We're at moles of Fe3O4, and now I just have to do a mole-to-mole problem. So then I'm going to put, for every 1 mole of Fe3O4, I have 4 moles of H2. Questions? And so my answer for that one, I'm going to go ahead and give the answer for problem 171. So you can check your answer. 171 is 0.5882. 0.5882 moles. And 172 is 10.8. So if I do this calculation, I should get 10.8. So, what I'm going to show you today is a mass to mass. I'll do one for you. Mass to mass incorporates these last 2 together. Okay? So, a mass to mass would be this for this one. Instead of finding grams of H2 or moles of H2, you're finding grams of H2. So I just take this one step further and find the grams. That's all it would be. Take grams, go to grams of H2. So let's just do that real quick on this one so you can kind of see what it will look like, and we'll do one real quick. So I'm going to go from moles of H2 to grams of H2. So then down here I put moles of H2, and up above I put grams of H2. So I know if there's 1 mole of H2, then if I add the 2 hydrogens together, which is 2 grams, that'd be 2 grams. And then what I do is take 10.8 and multiply it by 2 grams. Okay, so then I get 21.6. That's how many grams I have. So that's the only thing that's different from this problem. You take it one more step further. Okay, so we're going to look at doing a problem, and the problem we're going to look at is problem 173. So look at problem 173. This type of problem is called a mass to mass problem. Mass of A to mass of B. So this is problem 171A. Oh, I'm sorry, 73A. The first thing I like to do is I like to write out the equation. Some of you don't like to do that, but I think it's going to be helpful to kind of know where you're at. 173 says calculate the mass of silver bromide. So which one of these is silver bromide? AgBr, right? So when you got a word equation that you're reading through, and it gives you names of formulas, you've got to transition that and get the right formula. So what's the grams of AgBr that's going to be made? That's what I want to find. Okay, so what else do they give me? They say you have 22.5 grams of silver nitrate. So we got 22.5 grams of silver nitrate. We're going to make this easier for you. I don't know if I should or not, but I'm going to. Let's go ahead and map this out before we even write anything in. Okay? So what's the first thing I need to do? What do I need to get this and change this to? Moles. So I've got to go down here to moles. What's the next thing? Mole to mole. Right? Second step. Third step. Mole to grams. Okay? So I'm going to start out with 22.5 grams of AgNO3. Go ahead and do the first step, see if you get it right. Now down here, I put the weights. So can you guys see those? 169.88 grams of AgNO3 would be how many grams are in a mole? And this is 187.77 grams of AgB. Go ahead and do the first step and see if you do it right.
So 119.
169 down here. 169.
Oh, 160.
Yeah. Is AgNO3. So you just had one silver, one nitrogen, 3 oxygens. You guys hopefully will know how to do that. So that would go down here, 169.88 of AgNO3. That cancels out. And then you go to moles of AgNO3. There's a tendency for students to put the 2 in here. You don't put the 2 in until you do your mole relationship. We're not there yet. So it should be 1. So I'm trying to point out common mistakes that students make. Anytime you do grams to moles, it has to be 1 mole. Okay? So now we're here. Go ahead and do the next step. We're at moles of AgNO3. Do the next step. Should have enough time. The next step would be follow my units and my symbols, or my formula. 1 mole of AgNO3 would go, I'm sorry, that should be 2. And then up above I'd have 2 moles of AgBr. Any question on that step?
Couldn't you write it 1 to 1?
Sure, you could. You know, you can simplify it, you can make it 1 to 1. But if you put the numbers in front of the formula, so we're right here. Okay, after that step. So our last step would be gram or moles to grams. So down here we have moles of AgBr. I still follow my units. And then up above, I'm going to put grams of AgBr. So down here, I'm not going to put 2, because I'm relating it to grams, and it's for every 1 mole. I'm going to put 1 mole, and up above, I'm going to put the weight. I'll have to calculate it, but I've calculated for you here. It's 187.77. You can read that. Kind of ran out of room. 187.77 grams. Okay, and after you would do that, you get 24.9 grams. I think you guys can calculate it and see.
I had 24.59.
24.59.
I could have put
You did?
I got point
I got 0.7.
Yeah, I don't know how you got that.
Okay, I'm going to show you a website you guys can go to, and I'm going to give you a couple problems to do as homework, but I want to show you this website, and we'll do a practice problem off the website to kind of show you how it works. Okay, I sent this out to you. It should be in your email.
It's 22.5.
Okay, this website, if you look up here, number 2 is what we just did, mass relationships. Okay? Number 3 are mole-to-mole problems. Those are really, really easy. You can go through and practice those real quick if you want to. And number 4 is when they're all mixed up. This would be like studying for the quiz on Friday. They're all mixed up. And you just have to go through and see what you're starting with, what you need to finish. So we're going to do one here that's a mass to mass. This will be an easy one to do. This one says how many grams of oxygen are produced from 89.4 grams of H2O2. And it's giving you the balanced equation. So I'm going to have you go through. I'll come around. Okay, I expect everybody to work it out. If you don't know what you're doing, then you can sure get my attention and I can help you. Everybody read that? Okay? Doing that problem. Grams and grams. Mass to mass. down the problem? Did you write down the previous problems? We're going through? The ones we did on the board. How come? I can't help you if you don't write them down. You gotta write them down. That's why I spent 20 minutes up there going through stuff. You gotta go to moles. Plus.
Dang it, I messed up. I got H2O instead of O2. Good thing I wrote it down, but it's not complete thing, so I might be off a little bit, but who cares? 916. What'd you get? What did I get? 44.
Show your work.
I did, but I messed up and deleted it.
Not on the calculator.
Well, no, I should have here, but I wrote down 2.792.
Did you get Graham?
Numbers and
I need to show the work.
What did you get? Winning two so slow.
Okay, I went it for one mole. I did that wrong then.
Yeah, I just used one for.
And it's 2.627.
How did I get 84 around that?
275.
Oh.
And then
It
take
should be 60.
Okay, now I got 42.
that. Okay, yeah, you're one.
I got 42.
What did you use for?
I got A. First
So I had 3. It's 89.4
That's why I got 44.
grams of H2O2.
Otherwise, I would have
Did you get?
Yeah, I just thought that. I did too. That's what I guess
One more into a bit. And then one. So the 2 should go one. And 32.
Is that right?
Use 32.
Wait. Jared, you don't know how to use it. No, I can't do it.
You can't go from grams of H2O to moles and moles. You can go from grams of H2O to moles of No, that's grams.
I wasn't gonna go for Lincoln. I'm gonna go for Lincoln.
This is grams of H2O. So why do you have 2 grams?
Go to.
Oh, I did 16.
You gotta find how many grams are in a mole. All of them. Okay. For those that are done, I'll show the answer for you in a second. But I'm going to give you 2 problems to do. Do 177A, add that to your assignment. So 177A on page 890 and 195D is in dog. Okay? Problem 195D on page 891. Okay? Do those 2 problems. 177A. 195D on 891. Okay, and I'll give this answer here in a second. Okay, so again, the answer would be 42.1.
Dude, I got it.
Now, what they'll do is they'll show you a little bit different way and shorten it. I wouldn't look at their example because it'll mess you up. But at least you get the answer. Okay? and what it's supposed to be. They're going to do some totals. What they do is they do some totals along the way. Wish they would do it the way we show set up. There's a lot there to show. So, okay? So I've sent that to everybody. You guys can work on that during the week. Practice those. Come in with any of those you need help on. If you get wrong, write the answer down, what it's supposed to be, and I can show you what you're doing wrong on those. Okay? Great opportunity for those who like more practice. Okay?